So today we are going to start with performance tuning. Okay. After writing SQLs, we can make the functionality in any of the way, but finally after moving into production, it is very much important to tune our application so that it will be executed in an optimization way. Okay, nowadays so many applications and so many enhancements came for only doing performance tuning. Okay. So that is the importance of performance tuning. Yeah. There are some new initiatives coming up to tune the application. That's it. No extra functionality they require, but they wanted the application to be executed in time, always, and with less resources. Okay, there may be two types of enhancements and performance tuning. First one is at the report level, okay, where they may have seen some delay in the report execution, so they wanted us to tune the queries of the ETL or to load the model tables and all. And the other kind of performance tuning work what we get is from the Teradata DBAs and architects who observe the production queries, and they feel that some of the queries are taking more than the expected time. So they found those queries and they will put it in an enhancement QC tickets, and they will give it to you to do the performance tuning of that particular sequence of SQLs. So then we have to analyze, okay, how we can make the queries better way, and we can move into production. So these are the enhancements nowadays coming up more. Yeah. So performance tuning is very much important part in Teradata applications. So let us see some of the standards and best practices we have to follow while writing the queries. Okay, and how to tune the queries when we have a complex query in front of us, and how to analyze it, how to start seeing it, okay, how it is performing, and how we can make it optimized. So those are the things we are going to see today. So this is a simple document, okay, which reminds some best practices which we have to follow, and these standards are not same across all the organizations. Okay. So you may have some new standards or some less standards based on the configuration of the Teradata. Okay, some of are common, but some of them are based on the Teradata configuration. Teradata DBAs and architects will provide you with the standard document which has to be followed to write Teradata code for that client. So those things we have to study well before we write in the codes and SQLs, so that you can write a better SQL. So first one, if you see, we have a statement called diagnostic help stats on for session. Okay, first of all, stats. Have we discussed statistics ever in any of the class?
No, I think
We did discuss.
no.
Okay, so let us see that. Teradata statistics is an important concept where the statistics on the columns would provide some extra information to the parsing engine so that it can use that information to come up with a better optimized plan of execution. Okay. So it is nothing but you can assume it as a landmark. Okay, let's say if we have an address, we have an address with a door number, survey numbers, plot numbers and all. Yeah, but we don't have a landmark. Then would it be difficult to go to that particular address? Right, yes.
It is
So
not that much.
yeah, it is not much easy to reach that place. We may have to put more efforts get to find this address, asking so many people. Even though you ask a postman with the door number, he may not be able to tell that much easy. You may have to refer so many books or some ledgers so that he can give you some guidance to go to that address. So it is not easy, okay, if we have only a door number, survey number and the place. Yeah. So would it be better if they give you a landmark, like, okay, beside that place, in so and so place, okay, beside SBI bank is there. So would it be easy to you to go to that address?
Yes.
Okay. So first we'll go to that SBI bank, and then we will go around some of the places like beside the SBI or in front of the SBI, only that place we need to search and we can get our address very much easily. Okay, so in the same way, okay, Teradata also have a concept of statistics. Okay, if we don't provide the statistics on the data of the columns, then it would be difficult for parsing engine to come up with a plan of execution. Okay, but in case if you able to provide some statistics about the data in the columns, that is how many not nulls are there, how many total count is there, how many distinct values are there in this particular column, okay, what is the primary index and how the primary index column is having data within it, is it a not null column, okay, if it is a not null, how many nulls are there, how many distinct values are there, how many total records are there. If we can provide such an information about the table columns to the parsing engine will be more confident to execute that query in a better way. Okay. So it is always recommended to provide statistics for required columns. Okay. So how we collect statistics? Okay. To collect statistics, we have a statement called collect statistics on table name, column name. Okay. Let us try that. If we provide the statistics, these statistics will be stored in the database dictionaries, that is dbc.tables, dbc.statistics. There are so many other views or tables which holds this information about the column statistics. Okay. And when we try to execute any SQL on the particular table on which the statistics were already stored, then parsing engine will first see, okay, is there any statistics collected on this table or not. If the statistics are collected and they are up to date, then it feels very much confident and it can provide you the best optimized plan of execution. Okay. Like that, the statistics when we collect, they will be stored in the metadata tables and it will be used by parsing engine. Okay. We are not going to use the statistics explicitly. We just collect it and we have to forget it. And we may have to update the statistics whenever the data is being changed in the tables. That's the thing we have to do. The usage of the statistics will be purely by the parsing engine. As an user, we cannot use the statistics. We have to collect the statistics. We'll see in a simple example how the statistics would change the explained plan. Okay. So let's suppose I have a table. Select star from EMP. Okay, so this is the execution. How to see the explained plan of the query? What is an explained plan? We have seen three Teradata extensive commands, right? Help, show, and what's the third one? Explain, right? So this is the Teradata extended command. It is not an ANSI standard command. Here we have seen help, show. The third one is explain. So if you prefix the keyword explain before any of the SQL, it would give you the parsing engine plan of execution. And we have seen this in the explain command. Okay, what it does, it just gives you the English translation of the parsing engine plan. Okay, so first it will do a locking on the table. Okay, that is read lock, because we have given a select star from, so it is requesting a read lock on the row hash values on the table, and then okay, it will obtain the lock. First it will request for the lock, and then it will obtain the lock, and then it will do an all amps retrieve step from the EMP. Because I have given a select star from employee, so anyway it has to go to all amps to get the data of EMP table. Okay, by the way of all rows scan. Okay, in each amp, all the rows will be scanned with no other conditions. Okay, and it will pull the data into spool 1. Spool is the temporary space, the intermediary workspace of the Teradata. Okay, so it will spool that information into spool 1, and it is having a high confidence to be 9 rows. Okay, it is expecting 9 rows and it is having a high confidence. Okay, why it is having a high confidence? Maybe these statistics were already collected. So to see the existing statistics, we have a statement help stats on EMP. So let me see if there are statistics already collected. Okay, there are statistics already collected on the employee number, that is the primary index column and the department number column of the employee. So I just wanted to show you, okay, how it feels when there are no statistics collected. So I just want to drop the statistics. So there is the statement called drop stats on employee. Okay, so it is dropping the statistics. Now if you see, there won't be any statistics collected. Now if I see the explain plan of this query, now see there are no statistics, so parsing engine doesn't know any information about the employee table. Yeah, how many total goals are there, how many nulls are there, how many districts are there, nothing is existing in Teradata metadata tables. Okay, so now how it feels. Okay, so now also as select star from employee, it is an all amp operation and a all row scan in each amp with no other condition. Okay, and it pulls the data into spool 1 and estimated with low confidence because there is no information available. So parsing engine is very much low confidence, it is very low confident, and it is expecting 18 rows, whereas earlier it was 9 rows, right? Exactly, the table was having 9 rows only, right? Let us see what is the data. See, total we have 9 rows. So earlier when the statistics were collected, it was more confident about the data and it has given us the exact number, just so that it has exact estimations how much spool space it required to hold the data. But now what happened? It has low confidence and to be 18 rows. It is expecting 18 rows, so it is expecting so many bytes. Okay? And it is expecting 0.03 seconds. Finally, after spooling the data, it will provide an end transaction statement so that all amps will stop working on the SQL once the parsing engine got the data, and then spool 1 will send back to the user as a result. Okay, the total time is 0.03 seconds. Okay, so by seeing this, we can understand how much time probably it is taking, how many rows probably it is returning, how much space it requires to hold this temporary data, okay, and what type of operation it is going to perform, all row scan, all amps retrieval. Yeah, all these things you can see with the help of explain plan. Okay. Now if I collect statistics on the columns, okay, how to collect statistics? We have a statement called collect stats on employee column employee number. Okay, it is an index, the primary index column of the employee. I just wanted to collect statistics on employee number column of employee table. Now if I give the explain plan, see, automatically parsing engine become high confident and it is expecting the exact number of rows, and the spool space required is also estimated accurately. Earlier it is some 1000 around, right? Now it is 531 bytes and 0.03 seconds. In both the case the time is same, but the exact number of rows, the confidence levels, and the spool required, everything is estimated very properly. So if it has proper information and even we are joining this table with some other tables, it will come up with an best plan, okay, which is the smaller table, which is the bigger table, which table has to be spooled into the memory so that we can do the operations very well with less IO. All these things can be planned by the parsing engine very effectively if we have more information about the table columns. Okay, so we have to collect statistics on the important columns. When I say important columns or required columns, okay, how to identify what all columns we have to collect statistics. Is it all the columns of the table we have to collect statistics? Let's suppose I have 150 columns. Do I need to collect statistics for all the 150 columns?
No.
No. We have to find out, okay, which are required to be collected statistics so that parsing engine can use that information. Because why we cannot collect statistics for all the columns? Because collect statistics is also a very resource consuming operation. Okay, so this is an operation which requires all amps to find out the data, how they are, and it will collect the information. Right? So it is also a resource consuming operation, and if you collect statistics on all the columns irrespective of the usage, the performance, okay, the resources are misused. Okay, let's say I have one application, okay, the name is XXX. It has 100 queries total for extraction, transformation and loading, okay, and it is using some CPU resources like 4,000 units, 40,000 units. And in the application I have introduced some collect statistics statements. Okay, so I have introduced some 200 collect stat statements, and it is taking almost, okay, some 8,000 units. Okay, not 8,000. Let us put some 20,000. Okay, 20,000 units. So do you feel it is a better application?
No.
Right? Because collect stat is also a resource consuming operation. The total application is taking 4,000. Out of that, 50% of the resources we are using only for collect statistics. Okay, so this application will come to you again for the performance tuning to remove unnecessary collect statistics. Okay, so before introduce collect statistics, we have to do a thorough analysis, okay, on which columns we have to collect statistics. Okay, we have to collect statistics on the columns which are used for the conditions. Okay, conditions, when we say where clause columns, case columns, joins, okay, what else? So if the columns are being used in any of these conditions or joins, case statement, okay, coalesce, null if, all the case variants, okay, basically, okay, if we apply any functions, arithmetic functions or group by, yeah, having analytical functions, it means ranking, csum, if we apply any of these functions on the columns, it is better to collect statistics on the columns. Okay, so we have to find out in SQL, okay, what all columns are used in the where clause, case statements, joins, group by, having by clauses, analytical functions are applied on the columns. Okay, we will find out those columns, and for those columns only we collect statistics. Okay, so this is the first point. And when we collect statistics, do we collect statistics every day irrespective of change in the information, change in the data of the table? Okay, let's suppose I have given an address, okay, the landmark and everything was given to you. Is it required for me to give you the landmark every time when I say you the address? Once I tell you the address and once I tell you the landmark, it would be enough until I change my address, right? Otherwise it is not required every time I give you the address and the landmarks. Okay, so until the table data is changed almost 10%, I no need to create or I no need to update the statistics, because collect statistics is a resource consuming operation. Let's say I have some million records in the table. Now I have changed only one record, I have updated one record, I have inserted one record. Okay, I have deleted another record. So do you need to collect statistics for this change?
No.
I have some million records and I'm changing 3 records out of them. So it is not make much more information to the parsing engine because it has information about all rest of the 1 million records, right? 1 million minus 3 records. It is not making much sense to parsing engine to update the statistics because to give the statistics of these 1 million records, it has to put more efforts, more resources. Okay, so it is a thumb rule. Okay, it is also depends on the organizational standards because some organizations may tell you 20% of the data change, some organizations may tell you 10% of change. Okay, so we may have to follow them as per their configuration and best practices. Okay, so generally we feel 10% of the change in the data requires the updation of statistics. Okay? If out of 1 million, if you are changing at least 1 lakh records, then you may have to come up with the updated statistics. Okay? And in case here we have a complex query and there you are analyzing to get the statistics. Okay, then you may have to use statements such as diagnostic help stats on for session. Okay. So when we activate the diagnostic help stats for our session, and when I write any SQL and I request for the explain plan, it will try to recommend me what are the statistics are required for this SQL. Stats on for session. So now let me drop the statistics again. Okay, now I don't have any statistics. Okay. When I give explain select star from employee, okay, it is giving me low confidence, but it is not recommending me any of the statistics. Right? It is just giving me low confidence. If I am well experienced, if I know, okay, index column is not having statistics, that's where it is giving the low confidence, then I will go and collect the primary index collect statistics. But sometimes when the query is very much complex, we may not be in a position to identify what all columns we need to collect statistics. So we have a statement called diagnostic help stats on for session. Diagnostic help stats on for session. Diagnostic help stats, a combined word, on for session. Okay. I'm executing the statement. So the help stats diagnostic is on active for my session now. So if I execute any explain statement, okay, then it will come up with the recommendations also. Let's try with some complex query. Yeah, so let me write a join query. Select p number, p name, comma d name from emp inner join with dept on. Let me give alias employee and department e dot dept number equal to d dot dept number. This is a simple join where I am trying to get information from both the tables, employee and department. So there is my SQL. If I try to see the explain plan, and let me see if the statistics are existing on both the tables. How to see the statistics existence? Help stats, DMP and DAPT. Execute this. There are no statistics defined on the table. How about DAPT? There are no statistics. Okay, so on EMP and DEPT we have no statistics. Now I'm trying to see the explain plan of this query. So this is the plan. As we have given diagnostic help stats on for session, it is giving us the recommendations. Okay, because no statistics are collected on both the tables. I have given some a bit complex query with the join. So it is coming up with the plan with low confidence. And then again, okay, index join confidence, because DEPT number is indexed in DEPT table. Okay, and then total it is taking 0.06 seconds. Okay, so to improve this, to improve the confidence levels and the spool space requirements, it is giving some recommendations because we have given diagnostic help stats on for session. So it is recommending us to collect statistics on this column. Let me collect it and see what happens. I have collected the statistics. Now I am seeing the explain plan. See, now there are no recommendations, and it is not improving the plan also. So earlier we were having same 6 steps, same confidence levels, everything is same. Yeah. So actually what happens is, if it is very much complex query, we use this diagnostic stats, diagnostic help stats on for session, so it may give some 4 to 5 recommendations. Okay, so we will try to apply one by one statistics recommendation, and we will see the explain plan if it is changing any of the resource levels. Okay, if it is impacting or if it is reducing any of the resources, then we will keep that statistics and we will go for another statistics to apply. If it is not making any difference, then we will drop that statistic and then we will try for another statistics to apply. Okay, so whatever the diagnostic help stats on for session is giving us recommendations, not 100% true. Okay, so we have to do more analysis, because out of 150 columns we may not be able to verify okay what all columns we need statistics. So we can use this diagnostic help stats. Once it gives 10 recommendations, out of 10 recommendations only 5 may work for you. Okay, so we have to do more analysis on optimizing the SQLs. Whenever we are migrating any SQL, a single SQL into production, we have to do all these things. We have to see the explain plan of it. Okay, you identify what are the columns to be collected statistics. Okay, probably the primary index columns we have to collect statistics. So do the collect statistics on primary index. Collect stats EMP column E number. This is the primary index column. Most of the times it would work. So let us try that. See, even though it was not coming in recommendations, okay, as per our experience, if the primary index column is collected statistics, it is getting us the high confidence levels. Okay, like that, some of the recommendations may work from the recommendations, some of the collect stats, okay, as per our experience, would give us more performance. So we have to try each and every one, see the explain plan. If there is any change, keep that statistics. If there is no change, remove that statistic. Okay, that is how we analyze how the statistics should be collected on the tables and when to collect statistics. All this analysis we have to do before migrating any single SQL into production. Okay. So stats should be collected on columns of where clause, joins, columns of case statement, indexes, so that it would be preferable. And after collecting these statistics also, you feel some other statistics you are missing, then you can go for diagnostic help stats on for session and get some more recommendations. Try to apply them. If they are making any difference, keep it, otherwise remove them. And collect stats usage should be done on production tables only, and if there is a change in more than 10% of data. Okay, so it is not recommended to collect statistics on temporary tables, because temporary tables are loaded once and used once. But in production model tables, okay, once we load the final tables, they may be used by so many SQLs, so many reports. Right? So it is better to collect statistics on this query so that the resources used to collect statistics would worth off, okay, used by many of the users. Okay, so we have to collect statistics on the final target model tables which are applied with more reports. Okay, and that too whenever 10% of data is changed in the table. Okay, the change, when we say, that includes addition, deletions, updations, all the things. Okay, unnecessary collect stats will result in overloading the system. Okay, if I introduce more collect statistic statements which are not useful, it will take the resources every day, which is not being used by the parsing engine. Okay, so we have to be very much careful to introduce the collect stat statements to analyze if the statement is really providing the use or providing real information for the parsing engine or not. And collect stats should not be done on empty tables, because if it is an empty table, the parsing engine would have the information already. Okay, the random sample would give the parsing engine that it has no data. Okay, so if the table is empty, it is not required to collect statistics on this table. Yeah. So any questions on collecting statistics? Yeah, how to collect, how to see the existence of the statistics, how to drop them, what is the use of collect statistics, when to collect statistics, on what columns we need to collect statistics. Clear?
Yeah. Yeah.
Okay. So now we'll see one more important topic called join index. Okay. So that is also to tune our queries. Okay, for example, let us see this particular SQL. When we deeply understand the explain plan of this query, so what it is exactly doing for giving us this join result, okay, it is requesting log on samples.e is nothing but employee table, and then DAPT table, and then it is applying lock on both the tables. So up to third step, it has acquired the logs. Then fourth step, what it is doing, it is doing an all amp retrieval from the employee table with the all rows scan, and it is making the data into spool 2, and after pulling the data into spool 2, what it is doing, redistribution of the data by the hash code of employees department number to all the amps. Okay, so what it is doing, it is retrieving the data from the employee table and it is redistributing the hash code values of the employee table rows based on department number column. Actually, by which column the rows were distributed in the employee table? The hash code is generated based on which column of the employee table? You want me to show the table definition? Okay. So now can you tell me based on which column the row hash values are distributed, or the rows of the employee table are distributed?
B number.
E number, because it is the primary index. Okay, the row hash values are generated and used to distribute across all the available amps evenly. Okay, that is the basic point of Teradata and basic point of primary index. everything. Okay, but now when we see the explained plan, what is happening here? The row distribution was already happened based on employee number, but here in this particular query, what is happening? The redistribution of the employee table, that is samples.e is nothing but employee table, but it is rehashing the data based on department number. Why it is required? Why it is rehashing on department number? Tell me.
Because
Because
we are joining two tables.
yeah, we are joining two tables and department number is primary index in one of the tables, right? So in DEPT table, the rows were already distributed as per the join column, but in employee table, the distribution happened based on employee number, but here we are joining based on department number. Okay, so if we assume in all the amps the employee table presence is there, DEPT table presence is also there. Okay, and when we are joining this, can we say all the rows of employee in an amp is having sorry, all the employee table rows in an amp is having all the required rows of department also in the same amp? Can we say that? In DEPT, the rows are distributed based on department number. In employee, the rows are distributed based on employee number. And when I am joining these two tables, can I say each amp is having the records which are required for join?
No.
No, because the distribution is different. The primary index is different, right? So to make this join happen, I need to have both the distributions same onto same amp. That means both the tables should be distributed based on a single column. So here what I require is employee table also to be distributed based on the department number. But is it possible? Can I choose department number as a primary index for my employee table? Can I do that?
No.
Right?
But we can create secondary index.
Yeah. First of all, why we cannot create primary index as department number in the employee table?
Because it's unique.
Yeah. It is having more duplication. It's not unique. The distribution is not even based on the department number. Right? That is the first reason. Okay. So what is the solution for it? I cannot choose department number as primary index for my employee table because of the uniqueness, duplication, because of the duplication. Yeah, but in the join, I have to join with the department number only. I don't have any other chance. Right? Whereas department number is primary index in department table, but it is not an index in employee table. Okay, so what is the solution for this? It is doing operation and it is trying to redistribute intermediately in this pool space. Okay, once it get the data of employee table, it is trying to redistribute all the data based on the department number temporarily. Okay, so that in spool, okay, where the spool is nothing but again on the amps only, right? In this spool, all the rows of employee based on department number and all the rows of department based on department number are gathered on each amp locally, so that I can do the join and I can give the result. That is what it is doing. Right? It is redistributing temporarily all the rows of employees based on the department number column, and then it is doing the row hash match. So in the next step, it is doing all amp join step from sample D by way of a row hash match. Okay, now as each AMP is having the employee rows of same department and department table of same department, so that it can do a row hash match. Okay, and then it is giving the merge join based on the condition department number equal to department number, and the result of this join will go into school 1. Okay, so it is giving completely 9 rows and the end transaction. Okay, so this is what every time is happening, that is redistribution of the rows and then doing a row hash match join. Okay. So let's suppose I have some 10 tables in which generally in real time the indexes will be different. Then can we estimate how much redistribution it happens in the queries? Okay, for each and every rows, okay, every table it will pull and it will do a redistribution based on the joins what we do. Okay, so many redistributions would happen and so many row hash matches would happen. Okay, so we are using many of the resources in a complex join. Okay, and let's suppose this join, this same join is being used by some 100 users per day 10 times. Then how many times? Totally 1000 times I am executing the same query every day. Okay. So I am doing redistribution 1000 times. I am doing row hash matches 1000 times. So is there any way I can reduce these resources 1000 times? Okay. To give the solution, we have a concept called join index. Okay. So join index is nothing but a subtable which would be created on the joined tables in such a way it would materialize the joined result in pump space. Okay, so whatever result we require for this join, everything is materialized and it will be named in pump space. Okay, and whenever I execute this query next time onwards, it won't redistribute the table, it won't do the hash match joins, but it will see if there is any join index existing in the metadata tables. Okay, the parsing engine will see if there is any join index existence for this join. If it is there, it will go and directly pull the data from that subtable, join index subtable. The join index subtable is nothing but the materialization of the result. So it will just pull the data from the join index table and give the result, as if it is pulling the data from a single table. Okay, so that is the way of optimization of the complex and more frequently used joins. Okay.
So,
Yeah.
so the question is, hello,
Yep.
the join index will create automatically or we have to create it?
We have to create the join index. So let's see. In my analysis, I found this join index is being used by many of the users many times. Yeah, and it is very much complex. It is requiring more redistribution and row hash joins. Then I will identify this as a candidate for the join index, and I will create the join index with the syntax called create join index as the total query. Now I will execute this. Create join index, index name emp dapt index. Okay, so this is the syntax of creation of join index. Create join index, index name as the query which you use generally for our join results. So what happens? It has created an object called join index, and it is having all the data of this join materialized in the tables, samples, tables, emp dept index. Is it there? It won't be available here, but if you want to see the existence, you can go and query the dbc tables. Select star from dbc tables where table name equal to emp dept index. Yeah, this is how we can query where this table is existing. See, it is created in samples database as a join index by TD user with the syntax of create join index. When we have created 2012 530, create timestamp, alter timestamp, everything is there. Okay, so the data of this particular join is materialized and stored in a table called join index subtable emp dept index. As a user, we cannot query directly on this particular index table. If I write select star from emp dept index, it won't allow me. Okay, you will say error in using join index, cannot select from a join index. Okay, so as a user, we don't have any permission to select data from this join index table. Who uses this? After we create, who use this join index? Because as a user, I'm not able to use. Yeah, the parsing engine. Okay, when let's suppose after creation of the join index, if I am trying to execute this query, it is giving me the result. Okay, if I want to see the explain plan of this query, okay, earlier it was doing redistribution and hash matching. Right now, let's see what happens. See, this is the simple explain plan now. What it is doing, I am executing the normal join query only, but internally the parsing engine will check if there is any join index available on this particular join or not. If it is there, it will lock that index table and it will retrieve the data directly from the index table without any redistribution, without any join matching, any of the other efforts. It just pulls the data and give the data back to the user. Okay. So this is how we can optimize our queries. Okay. But the drawbacks are it uses the pump space. Okay. To materialize all the result, it will use the pump space. So we have to do the feasibility analysis. Is it worthwhile of storing or materializing all this data in the pump space, okay, against the redistribution or not? If it is used only once in a day, is it good to go for a join index?
No.
Okay. If 100 users are using the same report or same SQL, maybe one time or two times per day, then we may materialize this in pub space so that whenever they execute this, it uses that pump space, that means the join index, and get us the information as if it is retrieving data from a single table. Okay. So this is called the join index. So join index is nothing but a subtable created in order to materialize the join information or join data. Okay, it is a subtable created and we cannot access this subtable directly. It is used by the parsing engine while we execute the same join again. And let's suppose, okay, I have created join index on this, and now I wanted to see the department number also in the query. Now if I execute, what happens? The join index was created based on employee number, ename and dname only, and now I wanted to see the department number information also in the select clause. If I execute this, can the join index be used by the parsing engine?
No,
Because
data is not matching.
data is not existing. Actually, department number data we didn't store in the join index, right? So if I execute and if I wanted to see the explain plan, now it has to do all the steps as it is like earlier. It has to pull the data from employee and redistribute it based on the department number, and then do the row hash match join between the two tables, which is a resource consuming operation again. Why it happened? Because we have introduced one new column which was not materialized in the join index. Okay. So while creation of the join index, we have to ensure all the columns of all the users are grouped. Okay. Let's suppose if I don't use dname here, I want only employee number and ename, otherwise employee number and dname. Now can this query use the join index? I have created
Yes.
with employee number, dname and ename. Now I am using only employee number and dname, which is the subset of the join index. Now can the join index be used in this case?
Because data is there.
Yeah, the data is there, so it can simply use that. Even though you require less information of the join index, it would be used. So now what is the summary of all these things? Whenever we are going for a join index, we have to analyze how these two tables are being used by multiple users. Okay, the join may be same for all the users, but the select clause may be different. Okay, so we have to use a superset of all these SQLs, the 100 SQLs, which are based on the same join, and we have to keep all these columns in the select clause. Okay, let's suppose a user 1 is accessing only 3 columns, and a user 2 is accessing 5 columns, user 3 is accessing 10 columns, then how many columns we have to expect in the join index? You have to go for superset of all the columns. That means, okay, if the columns are different, then we'll keep all the columns 10 plus 5 plus 3. If there are any common columns in all the users, then we will identify intersection of all these columns and we'll keep the required columns, so that any user, if fired on the same join, okay, then the join index should be used. If I put less columns, then there is a possibility that some of the queries may not be used in the join index. So we have to analyze the queries to identify what type of join index and what all columns we have to keep in the select clause while doing the join between the two tables. Is it clear what is join index? When to use? What happens when we use? Any questions?
No, it's fine.
Okay. So let's go ahead. While creation of the join index, if we put a where clause, where something like d.dapt number is greater than 30 or something. If I put a where clause while creation of the join index, then that particular join index is called as sparse index. Okay, the syntax is same, but with the concept where we are filtering out some of the rows to materialize into the join index, then that particular join index is called as sparse index. If you use a where clause and filter out the records of join result to materialize into join index, that particular index is called as sparse index. And one more variant of join index is if we are selecting any of the aggregated values in the select clause of join index, like sum of, sal, if something happen and if you happen to select aggregated values in the join index, then that particular join index is called as aggregate join index. Okay. So these are also variants of join indexes. Normal join index, which materialize the information of the join. If you use a where clause, it is called as a sparse index. If you derive some columns with an aggregate functions, then it is called as an aggregate join index. Okay. And we have single table join index. We are doing a single table and it is a join index. Can you guess what it is? Single table join index. Okay. So let us suppose we have joins and we have observed there are more joins on the employee table based on the department number column. Okay, and we are not sure how many number of columns are selected in the select clause. Okay. And with what tables it will be joined. Sometimes it may be DPT, sometimes it may be DPT1, sometimes it may be DPT2. There are so many department tables, okay, with which the employee table is being joined based on the department number column. Again, we are not sure what all columns are to be selected also. We are not sure with what table we are joining and we are not sure with what columns we are filling up. Then would a join index help me? If I create a join index on DEPT table and sometimes the employee table is being joined by DEPT1 table, would that help me? Hello?
Yeah.
No.
You will hear me, right? Okay. Okay, so yeah, the answer is no. Because we have created on DEPT table and we are using DEPT1 table in my join, so it won't help me. Okay, like that we have so many other DEPT tables, let's suppose. Okay, so the redistribution is being happen every time when I am changing my tables. Okay. So to avoid this, what we can do is we can create a single table join index on the employee table based on DEPT column. That means create join index as EMP single table index as select star from employee primary index. I will mention it as DEPT number. In employee, the primary index is employee number. Okay. And this, when this is being used with DEPT tables on DEPT number column join, it is being redistributed every time. Okay. So now I wanted to create a single table join index based on DEPT number row hash values. Okay. So my single table join index is created, okay. And for this join index, what is the primary index? DEPT
Department number.
Yeah. So for this join index, the primary index is DEPT number. That means the rows of employee table are redistributed based on the DEPT number, and this result of row hash of DEPT number of the department table are materialized with the name called EMP-ST index. Now let me drop my previous join index. Drop join index. I have dropped my earlier join index, EMP DEPT index. Now I wanted to see the effectiveness of the single table join index. Okay. So I have created a join index, single table join index on employee table with the hash distribution of DEPT number column. And now I wanted to execute my query. It's giving me the result. Let me see the explain plan. See what happened now. It is using my single table join index with the join of DEPT table, but it is not using my actual employee table. It is using the single table join index of the employee table with the DEPT number of DEPT table, because the redistribution is not required if I join with the single table join index of the employee table, which was already pre-distributed with the DEPT number column. Right? So the parsing engine will see if there is any way it can avoid the redistribution. So it identified there is a join index which was already having pre-distributed with the department number column. So it is used that, and the redistribution is avoided. Only the row hash match is doing with the single table join index along with the DEPT table. Okay, so a better execution of the join. Okay, what we are avoiding here, the redistribution, because we have materialized the redistribution result in terms of the single table join index. So parsing engine used that single table join index to avoid the redistribution, but it has to do the row hash match join, row hash match scan. Okay, so this is how a single table join will be used, so that even though you use DEPT1 table, DEPT2 table, DEPT3 table, and if the join is on employee's DEPT number, that single table join index can be used. So this is a way of reducing some resources while joining. So we can avoid redistribution, which is a costly operation. So this is all about the join indexes: join index, single table join index, sparse index, and aggregate index. Any questions up here? Then we will generally touch base with the other concepts of performance tuning. Okay. So when you see any of the structure like drop and create in any of the application, that means, okay, generally what we do for our temporary purpose, we create some tables. Okay, we populate with some data, and after the processing we'll drop the table, and tomorrow if the same script is being executed, it will again create the temporary table, it will populate the data, and it will drop the data at the end of the process. Okay. So that is the technique used, okay, while processing some intermediary data in the temporary tables. Okay. But when you see the type of construct, it would be very much better if you convert these to delete from the table. Okay. So instead of dropping and creating every time, okay, you create it only once and delete the data every day, so that next day it won't require to create the table, just it will insert the data and process it, and at the end of the day it will delete the data only. Okay, so how we are going to optimize? By converting drop and create construct to only the delete table. Would it help me to save some resources?
Of course.
Right. So when we do create and drop, these are DDL statements. When these are DDL statements, okay, the entry in the metadata tables, that is DBC tables, will be given and deleted every time when you create or delete the table, drop the table. Right. So to reduce the intervention of the metadata tables, you can go for a delete table. Okay, so that it is not required to create the table every time. So whenever I create the table, it has to make an entry in the database dictionaries, and at the end of the time, if I drop the table, it has to remove that table definition from the metadata tables. Okay, in order to avoid that construct, you can go for a delete table. And then the next recommendation is, whenever you create a set table, what is the primary index preferred to create on that set table? Okay, let's suppose if I'm creating a set table, what type of index is preferable?
This primary index,
Which primary index? Unique or non-unique?
unique,
Unique. Why?
because it will not allow any duplicate values.
In set table, actually it won't allow row level duplicates. And in UPI, it also doesn't allow the duplication values as per the primary index columns. Right? So what is the advantage I'm going to get if I have a combination set table with a unique primary index? Okay. Let's suppose the table is having some 100 columns and it is a set table. Okay. And this table is already having some million records and I am trying to insert one more million records. Then what happens? It is a set table having already 1 million records and I am inserting one more 1 million record. Then while inserting each and every new incoming record, it has to check all the columns, all the 100 columns of the table to see if these values are already existing in the table or not. If they are existing, it has to reject it as a duplicate record. So can we assume how many resources it requires to check all these new 1 million records against all these existing 1 million record across all the 100 columns to verify it is a row level duplicate or not. If it is a row level duplicate, then it has to reject it. Right? So these are the resources which are required for a set table to insert data into it. Okay, it is very much slow. If I have a set table and if I am trying to insert data, it has to take some more resources, some more CPUs to identify if the row level duplicate or not, and then only it has to allow it. Okay. So to reduce these validations, if I can go for a unique primary index on a combination of 2 or 3 columns, then for each incoming record, it would be enough to check only on these 3 columns to identify it is a duplicate or not. If these 3 columns are duplicate, then the unique primary index constraint is violated and the row will be rejected there itself. No need to check all the columns, 100 columns. Okay, it is enough to check only the unique primary index combination columns. Maybe they are 2 or 3. Okay, they should be less than 100. So we are avoiding check of all the 100 columns against all the new incoming 1 million records against all the existing 1 million records. Right? So that is how the combination is preferable. The set table, whenever we are creating, try to get a unique primary index created on the table. Then it will be the better performance. And then if I have a multi-set table, then what type of index is preferable? Okay. Multi-set, it means it allows row level duplicates also. So when it allows row level duplicates, no conditions are required. Okay. So if you want to have the unique primary index, you can keep, but the non-unique primary index, which also not require any validation, okay, this would be the best combination though. So the insert operation on the table is very much faster because no condition required in multi-set, no condition required in non-unique primary index. So whenever I insert data, it would be very faster. So if you go for a multi-set, it is preferred if you can go for a non-unique primary index, and if there is anything you wanted to validate on the index columns or anything, you can go with separate queries to identify duplicates based on the primary index columns and can remove them manually. So that the load operations would be very much faster here. The multi-set and the non-unique primary index. because Teradata is data warehouse compatible database. So whenever we say data warehouse, the data loaded in the table should be very much large quantities. Okay, so whenever we are inserting large quantities of data in the tables, okay, this makes significant change. If I have a set table and I am loading millions of data, it will take more resources to validate it. Okay, so the best preferable way in the data warehouse is multi-set and a non-unique primary index, so that everything can be inserted into the table. Once the load is happened, the batch loads through multi-load or through fast load, once you load the data, you can write some other SQLs to remove the duplicates from the table. Okay, so it is always preferable to go for multi-set with non-unique primary index, because without validations you can insert the data. And whenever it is required for you to go for a set table, you may find out for UPA. This is preferable. Okay, we are saying they are preferable, but it won't stop you to create a set table with a non-unique primary index, and it won't stop you to create a multi-set table with a unique primary index. Okay, nothing like that. You can create any of the combination with any of the type of the table, but they are preferable as per the standards and the best practices. Okay. And then while selection of primary index, okay, what all factors we have to consider? I think we have already discussed this in primary index. So these topics we already discussed. So this is just a summary of all the topics what we have covered so far. Right? So while creation of the primary index in a table, what are the considerations we have to keep in mind? The basic question again. Okay. While considering primary index, what we have to consider? The unique distribution and the usage of that particular column in the rest of the joins. Are we using this particular column more in the reports or in the SQLs, and how much uniqueness or how much unique distribution it can provide us? So these two factors we have to keep in mind while choosing a primary index on the table. It is not only the unique distribution, but we have to consider the usage of that particular column. So most of the people will answer, hey, what is the significance of primary index? They would say this the unique distribution of the data. But it is not. It is not only the unique distribution, but we have to consider how this column is being used in the report queries and in rest of the ETL queries or SQLs. And then secondary index. It is not recommended generally, but in case if you can prove that the secondary index can get us more performance, okay, we need to do a POC with the explain plans, and you have to show that as a white paper. Okay, so this query currently is being executed these many times, and it is taking these many resources. And if I create a secondary index, okay, these many resources are saved, and as this query is being used 100 times, it is saving 100 into that many resources. So if you can prove that, then only the architect will allow you to create a secondary index. Otherwise, generally secondary index is not recommended, because it is a subtable, it stores the pump space, and the manageability of the data is very huge, and you cannot apply the fast load and multi-load utilities. Okay? Multi-load in case of a unique secondary index you cannot apply. In case of non-unique secondary index, only multi-load can be applied, but not the fast load. Right? So when we have a secondary index, there are so many other things we have to decide on. So generally they won't allow you to create a secondary index, but you have to prove that, okay, these are the resources I'm saving based on this secondary index. Then only they would allow you. Okay? So even though some utilities are being executed on the tables which are having secondary index, but they may come up with a workaround solution that before loading the table, drop the secondary index and then use the utility, and then after load through the utility, then recreate the index. Okay, so we have to calculate the resources. Sorry. Okay, we have to calculate the resources required for dropping the index creating the index every time, and then the usage of the index in the rest of the SQLs. We have to do that feasibility analysis and show okay how many resources on the net we are saving it in spite of creation and dropping the index every day before we load through the utility. So all these factors we have to keep while we are preferring or we are proposing to creation of the secondary index on the table. Any questions up here? Okay, shall I move ahead?
Yeah.
Okay. And then case when, null if 0. Okay, all these case variants are also not preferred to use. Whenever it is necessary, then only we have to use these. Okay. So sometimes unnecessarily they may use some Coley statements, null if and case when. So we have to be very much careful while writing the code. Wherever it is unnecessary, okay, we may have to remove such type of case variants, because case variants are also resource consuming operations. And then compress. Compress is another concept in Teradata to have a multi-value compression in Teradata. What is multi-value compression? Let us suppose in a table I have a gender column. Let's suppose in employee table I have a gender column. Let's suppose I have 1 lakh employees. How many types of genders I could have in the employee table?
2.
It is always 2. Even though my employees are 1 lakh or 2 lakh or 1 million, the gender type is only 2, either male or female. Right. So if I save only either male or female in all the rows of employee, okay, how many bytes it is required? Let's suppose in the gender column the possible values are female and male. So either I save this data or this data. It means 4 bytes or
6 bytes.
6 bytes. Right? So if I save this data in each and every column, sorry. Okay. So if I save this 6 bytes, if I save this 6 bytes, oh, I'm getting echo. Okay. So if I'm saving the 6 bytes, almost half of the data, right? So if let's suppose, okay, I have 1 lakh records. Out of 1 lakh, 50,000 are of female, 50,000 of some male. So how much space I require to save the data of my gender column? It is 6 bytes into 5,000, 50,000 plus 4 bytes into 50,000. Okay. So it is almost 3 lakhs and 20 lakhs. Right? 3 lakhs and 2 lakhs. So it is almost 5 lakh bytes. Yeah, I'm using 5 lakh bytes of memory to store my gender information here. Okay. Instead of storing this information every time for every row, okay, how it would be if I can store this in some space like amp headers, and I will point these values whenever they are required to be stored. So whenever I need to save female information, I will just point the memory location in which this female data is being stored, Okay? And whenever I need to store mail information, I just point to that memory location which mail information is stored. Yeah, I'm not actually saving all these bytes in each and every row, but I will point that information to the where exactly the information is stored physically. So for pointers, it won't use any memory, let's suppose. Okay, or maybe a 1 bit it requires. So comparatively, they are stored in only once. So how many bytes? 6 plus 4, 10 bytes. And all remaining are pointers. Okay, so 1 lakh pointers. So 1 lakh bytes, 1 lakh bits. So 1 lakh bits by 8. So it would come around something like 1000 bytes, okay, roughly. So totally I'm using 1010 bytes if I use pointers to the information, okay, against the 5 lakh bytes. Okay. So how we can point this information? Okay. To point this information, we have a facility called compress keyword. Okay. So while creation of the table, if you identify such a column that is particular values are repeated in the table, then we can use compress female and male. Okay. So when I identify this column, gender is having only 2 distinct values always, then what I can do is I can compress these 2 values while creation of the table itself, so that whenever I enter female or male, the values are not stored in the actual rows, but they are stored in the headers and pointed whenever they are necessary, so that I can save some space. Okay. In the table, if I can identify some 10 to 15 columns such that, let's suppose department number. Okay, if I have only 5 department numbers, then I can compress all these 5 department numbers here, so that whenever this department number is being stored, it won't store the actual data, it will store only the pointer. Okay. If there are any other columns where I can do the compression, that means the number of distinct values should be less than 10 or 15, let's suppose. So we can identify that column as candidate for compressing the data, then we can create that table along with the compress options. So the table size will be significantly reduced. Okay, so when the table size is reduced, whenever it has to be pulled into spool, the spool space will be reduced, and whenever the space is less, then the CPU time to process the data would also be less. So in terms of CPU time, IO time, everything, it would give us the optimization. Okay, the compression won't give you the optimization in terms of space, but in terms of CPUs and IOs also, it will result you to give the better performance. Okay, so it is always recommended to profile the data and identify the columns, okay, with, okay, identify the columns which you can compress with the more frequent values and less distinct values. Okay. So that is all about the compression. So we have to identify the columns which are having less distinct values and add compression and constraint while creation of the table itself. It will reduce space and it will help you in processing of IOs and CPUs also. Any questions in compression? Okay. Again, BTQ. Okay, is BTQ for load jobs. The number of records are less than 1000. Okay. In some organizations they will say 1000. In some organizations it may be 10,000. Okay, based on the actual size. Actually, if the table is very huge, then it may be 1000 records. If the table is very small, then it may be 10,000 records. So it all depends on the data size which we are processing through the utility. Okay. And again, we have T-pump, which is similar utility of BTQ, which is also a low utility of row level operation, okay, which can take up to 4 input files and can load up to 120 tables in a single session. Okay, but it is very much dangerous utility because it is used for managing the active data warehouse. If you have a requirement to load an active data warehouse, then only we will go for a T-pump. Otherwise, the sessions of T-pump are always open and it will consume so many of Teradata resources. If we don't close and if we don't manage the sessions, it will occupy all the Teradata sessions and it will give bad performance for all other users. So it is very much difficult, or if it is very much complex to use T-pumps. So whenever we have an active data warehouse maintenance, then we go for a T-pump. Yeah, otherwise you better go for either BTQ or any other load utilities like fast load, fast export, and multi-load. And then the data conversion operator and string functions. The usage for this data conversion and string function should be very much minimal. Whenever it is required really, then only we have to use that. Okay. We have seen some SQLs where the cast is unnecessarily used. Okay, so once we cast to some other data type and we'll recast it to some other data type. Okay, instead of that, we may cast it to the direct destination data types at once. Instead of doing so many intermediate casting, we may come up with a single casting sometimes. So avoid using casting and substring functions wherever it is possible. And whenever we have to delete a large table with huge data, then better go for multi-delete, multi-delete, you can say. In mload, we have two tasks, import task and delete task. It is better to go for mload delete option whenever we need to delete a huge amount of data from the tables, okay, instead of BTQ or SQL Assistant. If it is a BTQ, then it has to maintain all the transient journals and all. But if it is a multi-load, it won't require the transient journal. So the resources are very less used and it is very faster also. Even though it failed, it can be restarted from the last failed point onwards. But in BTQ, if something happens, then it has to start from the first record onwards. Okay, after implying the before image, it has to start from the first record onwards. So multi-delete is very much optimized to delete large number of rows from the tables. And in any of the utility, majorly in BTQ, each and every SQL statement should be handled for errors. You have to validate what is the error code happened. If it is greater than or equal to 8, then we have to control the execution to the end of the script without executing all the remaining SQLs in the script. Okay, so this is the best practice. Okay, whenever we have a failure at an SQL, we have to direct that execution to the end of the script, skipping all the remaining SQLs, so that after fixing the error, if you re-execute the SQLs, it will run successfully. Otherwise, it will even a SQL is failed, it will try to execute all other SQLs and it may keep your tables in an inconsistent status. Because some SQLs executed, some SQLs not executed, so it makes your tables inconsistent, and you may have to do so much of rework to make these tables to the previous status and then rerun the job. So it is better option or best practice to handle errors at each and every SQL statement of the BTQ, so that whenever error happens, it will go to the end of the script, avoiding execution of all the remaining SQLs. In code review, actually we have to keep this as a checkpoint. Whenever you are having an opportunity to write a BTQ or review a BTQ code, then we have to use this as a checkpoint. Each and every statement of BTQ is used for the error handling or not. And checkpoint limits. For multi-load jobs, checkpoint should be done for each 5 million records. It is also the organization-wide standard. Okay, how many records they wanted to have a checkpoint, it depends on the organization. So you may have to get the new standards whenever you get, okay, you have an opportunity to work on Teradata load utilities. You have to get the best practices standard dedicated for the organization or for the client, so that they will give you how many sessions they have to use in the multi-load session, a multi-load script, and how many records, for how many records we need to add the checkpoints. Everything will follow that document. Grant all is a DBA related statement. We should not put this grant commands in any of the scripts which are productionized. Okay, so if we are giving grant to the tables to external user IDs through our production scripts, then it may cause some confidentiality issue. Okay, so it is recommended not to put grant statements in the scripts which are productionized and which are executed every day. And then varchar versus character. When we have to go for a varchar, when we have to go for a fixed character length data type. When we have data less than 5 characters, then it is better go for the fixed length character. If the data is more than 5 characters, then you may go for a varchar. Why it is? Any clue? Why we have to go for a fixed length character when the data is less than 5 characters, and why we have to go for a varchar if the data is more than 5 characters?
I mean, in a varchar, if the data is greater than 5, for example, let's say this 7, but we are getting the data of only 5 characters for that varchar, it will not waste those 2 spaces.
Yeah. The overhead 2 bytes. Okay, so whenever we use a varchar, it will use a 2 bytes of overhead to identify the exact length of the data what is being stored in that particular column. So if I have only 5 characters, if I mention it as varchar of 5, and if I'm storing only 2 characters, anyway there are 2 bytes of overhead. So it is already occupying 4 bytes out of 5. Okay, so it is not giving me worth saving any space if it is a varchar of 5, and against we are having a overhead of 2 bytes and processing the data. Okay, so it is better go for a fixed length character of 5, so that always it will occupy 5 characters, but it is not making much difference even though you store 2 characters or 5 characters. Okay. So if the data length is more, then the overhead of 2 bytes comparatively will give you more information. Okay, how many characters were stored and how much space we can reutilize for the other data. So it is better go for varchar if the data is more than 5 characters, and the fixed length character data type if the data is of up to 5 characters. Okay, this 5 is also not universal standard. It is also an enterprise wise standard. They may tell you 10 characters sometimes in some clients. Okay. And then group by and distinct. Which one is good to use? Group by or distinct? The functionality of both group by and distinct are same in case if you want to get the non-duplicate records as a result set. So which one you will prefer to use? When we have very much huge data in the tables, then it is better to go for a group by clause. Huge data and the duplications also very much high. Okay, so 2 factors. The data is very high and the degree of duplication is also very high. Then better go for a group by. Okay, if data is less and the degree of duplication is also less, then better go for a distinct operator. So it will improve the QA performance. Okay, so these are some of the best practices and rules which we may have to follow while writing Teradata code. Any questions? performance tuning, the statistics you have seen, and the join indexes, and then the remaining best practices. Any questions up here?
No.
So we are clear, and if we don't have any questions, then we have done with the Teradata portion.
Manohar, can we discuss like data warehousing, some of the concepts, dimensional modeling, and
Okay. So dimensional modeling. Okay.
is it possible tomorrow or?
Yeah. I mean, if we need, we can have a class tomorrow and we can wrap it up.
Yeah, tomorrow we can discuss.
So Mizan, is it fine?
Yes, some of the what is called interview question also, if you can
Yeah. I mean,
discuss
most of the times I'm referring the interview questions and all. So yeah, you can do that. So tomorrow we'll go with the data warehousing concept, the basics of data warehousing. So do you also require the warehousing concepts, Mizan?
I have concept. I wanted to see from
Okay.
you also.
Okay. Fine then. So we'll go with that in tomorrow's class, and then when you may come up with some other questions if you already encountered while execution and while going through your documents. So tomorrow we'll have the Q&A session. If you don't have any questions, I will ask some questions so that it will
Okay.
make you summarize of all the concepts.
Mm-hmm.
Okay.
So these are the two topics: the warehousing concepts and the Q&A, either by you or by me.
Okay.
Okay. So tomorrow will be the last class.
Okay. And could you please send today's discussion document and all?
Yeah, Word document I can send you. But for join index and all, we don't have any proper document. This is all dynamic. So and whatever you noted down, that would be okay. Okay, this document I can send you.
Okay.
Yeah, and these are the standards of some clients, where whatever I encountered. This may not be 100% true for each and every client. There may be some variations.
Manohar,
Yeah.
it's just uh, uh, what are the US clients that you work for?
Actually, I work for Sprint Nextel, and I work for DBS, Development Bank of Singapore, and I work for Bank of America.
Bank of America in which location?
Charlotte.
Oh, Charlotte.
Yeah.
Okay.
Okay. So I have sent you the document. Please go through and come up with all your questions by tomorrow. Just put some efforts today to do all the background work so that we can have some volume of questions tomorrow. Okay.
Okay.
Yeah. Thank you.
Thank you so much.
Yeah. Bye.